Hey, good day guys, this is Adrian from Elite Educators, and today what I want to show you guys is just a sample of our teaching styles. Now the thing is, a lot of teaching out there, whether it be at primary level, secondary or tertiary level, they use old school methods like chalk and talk, where they just write stuff on the board and they expect the students to just copy it down. Now, in my studies and in my long career as a teacher, forensic science, everything, that is not the best approach in most instances. Once the student understands the particular topic, they have a tendency to remember that topic for way longer than just the essay exam. So what I want to do is give you guys an example of how textbooks have it, how some teachers teach it, and how we would teach the same exact topic. So this is one of the most popular topics on the essay exam. You can check all the past papers, they will have a question on place value of any whole number. So you get a number and you have to know what is the value of a specific number in that entire number sequence. So the regular textbooks, what they do is they just give you this place value chart. So what it does, it tells the value of a particular digit in a number. Now, they usually advise kids to memorize this chart. Now, when I was a student, I was the worst at memorization. I was a troublesome student, so I would have a tendency to just forget it sometimes and not learn. So, say for instance, we have a number like 324. So you take that, you memorize the chart, and you actually put it into the chart, so 324. So here we would see that there would be 4 ones, 2 tens, and 300s. Now from the syllabus objective, there are a couple other set of syllabus objectives that if the student doesn't understand this concept, they won't be able to continue and do the rest of concepts. So instead of memorizing this, what we would do is we would tend to tell the students stories. So for instance, we would tell the students something to the effect that, I want you to imagine that, talking to the students, I'll use a different example. So I'll tell them probably imagine Fortnite is about to release a new update, or one of the mobile games that they play a lot is about to release a new update in 20 to 30 days. And then I would have the student start to count one by one on the board. So I'll show you guys in a bit, but just for this example, I'll use something more relatable. I'm super hungry, therefore I will use KFC. So let's say KFC has Customer Appreciation Day in 30 days. And this is just for example, I want to know how much time has elapsed from today so that I'll know exactly when KFC Customer Appreciation Day is. So what I would do is just X that out. I would start to put markings on the wall. So every single day that passed, it put 1, 2, 3, 4, 5. So 5 days later, after I started the countdown for KFC, we would actually see 5 marks on the wall. So far that's not bad. That seems like a decent way of counting in terms of digits and keeping track. But since we only have 1, 2, 3, 4, 5, that's a small number, so we have no problem in keeping that in check. We have absolutely no problem in counting it. But what happens as the days go on and on and on? So we keep going, and we keep going, and we keep going. So if we want to find out how much days passed, we would have to go and recount this entire thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So far, 14 days have passed. And this is what the earliest set of people, the cavemen, this is what they did. Their number system wasn't as advanced as our number system, which is hexadecimal, but leave that out for a bit. But what if there was an easier way that we could keep tabs of this, right? So let's just keep going, right? So let's just say a couple more days has passed. Day by day by day by day by day. Boom! We're closer to that extra piece of chicken that you'll get free for Customer Appreciation Day. So yes, 10 out of 10. So what if there was an easier way? This is where our number system comes into play. we've started to group things in groups of tens. So let's just say we have 10 fingers. So let's start to group things in terms of tens, right? So what we can do is we'll count 10, we'll draw a red line around it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have one set there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, draw next line. Just for demonstration purposes, we'll add a few more days, right? So instead of having to count all the notches every single time, we can look back on this and you guys can see this. We have one group of 10, and we have another group of 10, and then we have 3 ones. So basically with this, what it is saying is that we actually have 2 groups of 10s, and we have 3 ones, which would be 3 times 1, right? So in total, this would be the number 23, right? So because we know that we have 23, we look back at the diagram, we have 2 groups of 10s. So here, kids would actually get another part of the syllabus, which is visually and pictorially representing numbers up to 1 million. So this way we kill 2 birds with 1 stone. So we continue in the story, and we're saying now that we actually have this method in place, we are able to decode numbers. So instead of kids going, and let's say we have 23 here, instead of kids just memorizing this entire framework, now the child would actually know exactly what it means. So further on in class, we also give handouts, so we don't expect kids to write down anything unless it is super important, because I notice a lot of time is wasted on just students writing down work that they don't understand. So in Elite Educators, we believe in handouts and going through the handouts with our students. Plus, we provide everything from markers to pens to highlighters to bottled water to even envelopes too. So once your kid is by us, they are fully covered for all of the materials necessary. So this is just one example in maths. So as we can see, we got the number 23, and we actually showed how that number was derived. So instead of just memorizing the table, the child is actually now able to tell you, this 23 is equivalent of 2 by 10 and 3 by 1. And thus,